Alrighty, everyone, welcome to day 9 of Advent to Code, the last single-digit day. We will see what's in store for us today. Get right into it. Go ahead, grab our puzzle input. Wow, it's a long puzzle input, but this looks like it's going to be pretty short in terms of the read, so that's pretty good. These caves seem to have lava tubes. Parts are even still volcanically active. Small hydrothermal vents release smoke into the caves that slowly settles like rain. If you can model how the smoke flows through the caves, you might be able to avoid it and be that much safer. The submarine generates a height map of the floor of the nearby caves for you. Puzzle input: smoke flows from the lowest point of the area it's in. For example, consider the following inputs. Each one corresponds to the height of the particular location, where 9 is the highest and 0 is the lowest. Your first goal is to find the low points, the locations that are lower than any of the adjacent locations. Most locations have 4 adjacent locations: up, down, left, and right. Locations at the edge of the corner have 3 or 2, respectively. Diagonal locations do not count. For example, there are 4 low points, all higher than 2 are in the first. Okay. The risk level of a low point is 1 plus its height. In the above example, the risk points are 2, 1, 6, 6, the sum is 15. Okay, so we have to find all these risk points out of here. Oh boy. I mean, we can just brute force this. This is short enough that we can brute force this. So let's do that then. So what we're going to do is, I guess, just convert this to a 2-dimensional int array. Again, brute forcing is fun. New int array. It's going to be input dot size because it's row column, and then it's going to be input get 0 dot length. All right, and then we're going to go for each string s in inputs. If I can spell. Actually, sorry, we can't do that. So we got to do ints. So for int row equals 0, well, row is less than map length row plus plus. Go with that, and then the string s is going to be equal to inputs get row. Row. This is now the column. K makes it easier to do mapping. And then now we can do the int value is going to be equal to s dot. Let's just substring it from column to column plus 1. Make it easier because we can just integer parse this. I could do the fancy logic with getting the char and converting the char to a number. I'm just not gonna deal with it. This is fine. And then we're gonna simply just do map row column equals value. Sweet. We can actually simplify this a little bit to go with that. Okay, so now that we have the map built up, it's pretty easy to go through them. So we just go again, do this exact same thing. And all we have to do now, actually we have to keep track of the sum. So let's just do long sum. And all we have to do here is do a check around the row column. So we have here, so we have to do first if row minus 1 is greater than equal to 0. Well, first we need the value. So int current is going to be this. And so we're going to do check then. So if it's that, and or no, sorry. If yes, both. Okay, no, we're fine. So if it is greater than or equal to 0, then we can do current, and the current is less than, yes, and the current is less than the map of this, then we can go ahead and just continue because this is a non-valid location. So pretty easy, and we're just going to do this for all 4. So there's row plus 1, and this is going to be if row plus 1 is less than map dot length. Yes. And this is going to be row +1. And then now we can set the column. So column -1 is again greater than or equal to 0. Column -1. And then column +1 is less than the map of the row dot length. So if it is, no wait, if the current is greater than, sorry. If the current is greater than these values, that means it's not a low point. We continue, and so then we can just go to here, sum plus equals current. I think that'll do it, right? I go lap of sum. Let's see if this works. I'm curious if I did this correct first try. Nope. Okay. Let's take the example puzzle inputs. Let's try this first. We should see. Oh, you know what? It's wrong. It's 11. Haha, it's actually right. I am right. What I forgot to do was add 1 to the current. I gotta wait 36 seconds, but that should be our problem. So we'll wait a few seconds here, and then we'll see what's if we're right or not. I'm still wrong. Oh. Is it because I'm not doing, is it because I'm doing that? Oh my goodness, it's because I was doing, okay, wow. Alright, I figured it out. It's because I didn't have, okay. I had to go and like, I found another solution because it worked for me. Like I couldn't figure out what was going on. It's because I was missing, okay. Well, part 1's done. I already valid, okay. So part 1's done, on to part 2. Oh boy. Next, you find the largest basin so you know what areas are the most important to avoid. The basins, all locations eventually flow downward to a single low point. Therefore, every low point has a basin. Although some basins are very small, locations of a height of 9 do not count as being in a basin. What? Basin's location that eventually flows downward to a single low point. Therefore, every low point has a basin. Although some basins are very small, locations of height 9 do not count as being in any basin. Okay, so it's just we gotta figure out where it's surrounded by entire 9s. Okay. Okay. So, oh boy. So here's part 1. Good to know that you need these, are crucial. Okay. Alright, so part 2. So we have our low points. How do we want to determine I mean, we can do this. Okay. Let me do this. This is... I'm like, the easiest I can think of is like a breadth first search would be the easiest. And that's just what's coming to mind first. So let's just do a easy breadth first search, I guess. Or just a search in that way. Okay, so we're going to need we're gonna need a quick class here. This is gonna be called point public int x, or row public int column. And let me go ahead and make a constructor. I would faster not do this way, but sure. Okay, so we're going to need a up here. So when we do this first part, we're also going to need to find a list of points, which is going to be the lows And so what's this asking for? Find the 3 largest basins and multiply their sizes together. Okay. So we do here, so when we get to here, we're gonna do lows, add new point, and it's going to be row column. Easy enough. Okay, so now we have the lows. So we're gonna have to go first a for loop. P in lows. We need to then just do a vector search. So we do need a we only need to keep track of integers, so we're just gonna have a list of the largest, right? Yeah, largest. Right list. Okay. So for each of the points of the lows, we need to go through and do a breadth first search, or any breadth first or depth. They all work. We're going to do breadth because that's the one I can do without doing recursion, I think. We'll see. So we do need a list of points. This is going to be visited. And then we're also going to need a list here for to visit. And then we're going to do a while loop of while to visit dot size is greater than 0. We're going to continue on this process. We got to start off with in to visits, adding on this point. And while we do this, we need to keep track of the size, I guess. All right, so the first thing we're going to do is we're going to do 2 visits, and we're going to remove 0. This will give us point P, whatever. This is the current point we're at. So we can't do P. Call this next point, sure. We'll remove it, and we'll increase size by 1. And then what we need to do is now we need to look around our current position. I'm going to steal this code here. It's mainly for this. So the next point dot row is going to equal to that, and it does not equal 9. Let's do this. Let's do int row. This might be a little bit easier to deal with. And these are all just going to be not equal to 9 because that's all we care about. Okay, so if this is not equal to 9, what we'll go ahead and do is we go ahead and we do, well actually first we do visited, add next point as well, because we've now visited it. We can now do a point, this is down, and it's going to be row -1 column. We do need an equals here. Equals. This will do it for me, which is nice. So this equals here is just so that way we have the equality check for the equals on the list. So first check to make sure that we haven't visited it. First, yeah, make sure that we haven't visited it. If we haven't visited it, then we can go ahead and put this into 2 visits down. Cool. And then we repeat this process for the other 4 of these. And then just change it up. So this is going to be pull, this is going to be up. And this is going to be left. Oh, that's left, left, there, and then last but not least, right. And that, oh, why is that there? Okay, and so now that should go through, calculate our size, and correctly return the size of what this little pool is, or what this basin is. And so after this, what we're going to do is we're going to do for and I equals 0, while I is less than 3. We're just gonna go through all of largest. So we're gonna check if largest, actually first what we're just gonna do is we're gonna do if largest dot size is less than 3, largest add size. Otherwise, now we can do the else, which goes through this process of actually calculating it. So then we get largest dot get I is less than size. If it is the case, we can then do largest set. Yeah, set I to be size, and then break out of this. And that will then conclude this point, and that should conclude all the points. And then at the very end, we should be able to do lap of largest 0, and just add the 3 together. It's adding, right? It's not multiplying. Multiplying. Okay. Should be able to multiply these 3 together. So we're actually going to make largest be a long, just to avoid that issue with size also becoming a long. And that should hopefully now give us a second answer. Nope. Okay. Well, back to this. Let's see where I was at. Well, this needs to be flipped back, so I was playing around with this. Length, map, 0, length, actually it's row. Oh. And what's this one example? Okay. What am I getting here? Nope. It's on the wrong spot too. What am I largest here? What am I getting? 13, 10, 23. Huh. Well, that's not right at all. Oh, we also have to check real quick. If visited contains next point, continue. I forgot about that. Because we could just somehow get duplicates entered in. 9, 9, 14. There we go. That seemed to be our issue. Try this again. Still wrong. Well, now we have the issue again where I'm right. But my answer is wrong. Where I'm right with the example, but what I do here, oh no. Oh, you know what? This is my issue here. It's this bit. I'm just replacing. Okay. I don't know. I think I see this. I see. I need to. What? No, because it's long. We need to do this and then here. Okay, so we can actually simplify this. We can just do if largest get 2 is less than that. I think that's my issue. Oh. Okay, well, this is also okay, apparently this will reverse. This is really inefficient, but this will reverse sort it. I guess, yeah, that'll do. That'll. Alright, please tell me now. There we go. There we go. Okay. Not ideal. Yeah, that was self-inflicted on so many levels. Yeah, so the issue there was that it was doing it, but my logic there was bad for actually adding on or keeping track of the 3 largest. What I should have been doing is always just comparing it to that third largest and then replacing that third largest if it was larger and then resorting that. That's how I should have been doing it the whole time. Let me clean up this code a bit. I don't know if I'll do too much, but let me clean up this a bit and then I'll get to my talking about how I solved this. So 1 second. Okay, actually wasn't much to clean up. This is actually done pretty well somehow, despite being so bad at this. But at any rate, the TLDR for today's question is that we are given this map, and we are essentially, for the first part, trying to find the low points. The low points are a point where we have a number. So here's like our input. Our point where we have, say, a number, and it's surrounded by numbers that are completely larger than it. So in this case here, we have this 2. It's surrounded by 3, 3, 3, and 3. This is a low point because all 4 points around it are higher than it. So we have to find all of these low points and do a little bit of math with them to get our solution. To do that, we first build up our map in code here. We go through, we initialize it, and then we go through our inputs, basically breaking this down line by line, and then each line, and then breaking out each individual number, and then adding it into our map like so. So we have a 2-dimensional integer array in Java of what our input is. Then after that, for part 1, we go through all of those points, and we simply say, all right, at this point, is the point above, to left, below, and to the right, are they all larger than this point? If any of those are false, or if any of those are false while being a valid location, so say if we're in the upper left, the up position and the left position are outside the map, so they don't count, we can ignore them, which is what this first check is here in all these, is make sure that we are in a valid check location. If you're in a valid check location, and the current location is, in this case, greater than the map value, that means we can break out of this because this is not a low point because our current location is higher than what's around it, so it can't be a low point. So that just makes it a little more efficient. That way we just end the checks there. But if all these are false and that we have valid locations and all those valid locations have a current point that's less than what is around it, we go ahead and add it to our sum, our rolling sum of all those values plus 1. I also, while doing this, keep track of all these low points. That way for part 2, it makes it a little bit easier. We'll get to that in a second. But just know that, and just know if my issue for part 1 was the fact that I wasn't checking equality. It needs to be less than as a whole. If it's less than, or if it's equal to the surrounding, it's not a low point. It has to be less than completely all of the around ones. For part 2, what we do is we use those low points we found in part 1. So this is what we built up this array for. We use those low points to go through all of them to calculate how large the basin is. The basin is basically, from that low point, all of the numbers around it that aren't a 9, how many are in that collection there, how many are in that basin, I guess. It's better if you look at the actual problem. These examples are pretty good in explaining what a basin is. But to do that, we first go through all the points, all those low points, and we do what is, I believe, called a breadth first search. I think this is what this is terminology wise. But basically what we do is we start at our sink in this case, or right? Sink, right? That's what they're calling it. Our low point. We start at our low point and we branch out from there. So we start at low point. We added to this 2 visits queue in a sense. Is actually what this is a queue. Add to that, and then we have this while loop here, which just pulls the next 2 visit points off the queue. Assuming we haven't visited it already, we go ahead and go to the next step. We add it to our visited. That way, we can't return to this, and this can't be counted twice in the size of the basin. So that's what the visit is here for. So we can't count a position twice. And then we go through just like above. We make sure that we go through all the 4 adjacent tiles. We make sure that the adjacent location is valid, and then we check to make sure that the adjacent number isn't a 9. If it's not a 9, what we go ahead and do is we go ahead and add it to the visit locations. This is where we should check in the future, and we do this for up, down, left, and right, just like before. And then we go back up and we start this whole loop again. So now, if say we are starting at this spot here. If we are here, we would say up is good, add it to visit, add to visit for right, don't add the down to visit, and add the left to visit. So after this iteration, to visit now has 3 numbers into it, and we continue this while loop again, and we remove the next one, so now to visit will have 2 values. Now the next point will be one of those 3 that are there. It has not been visited, so we continue this loop again, and each time we add more and more points to this, but eventually, because we have the visited list to track from, eventually to keep breaking out, and then it'll slowly go down to visit, so we have no more points to visit because they've all been visited. And at the very end of that, we can then go ahead and check if our visited list, which is the number of values in our sink here or in our basin, that's the total number of numbers in that. We can go ahead and check if there's not already 3 largest basins, we can just go ahead and add it, skip all this logic. If there are already 3 largest basins being tracked, we go ahead and we take the 3rd one, which is in this case, because it's sorted, it's going to be the smallest basin. We compare it to what our new basin size is. If this one is larger, we replace that 3rd one, and then we go ahead and resort the largest list and resort that and reverse sort it. That way the smallest current largest basin is now in the 3rd value. And at the very end, after we've gone through all of the low points and we've calculated all the largest, we can then output the top 3 largest basins multiplied together. And that's day 9. Not too bad, especially if we can get the bread first search. Bread first search makes this a lot easier. For part 2 is not too bad. Part 1 wasn't too bad. Both points I just got tripped up. First part 1 because of the equality check, I totally missed that, and in both cases I got the right answer the first time for the example, but I didn't get the right answer for my inputs, and so that's what it is. In this case, the second one was because I wasn't sorting the largest basins, and I was removing the wrong basins when I got a new largest. So at any rate, there's day 9. That's all complete. I'll see you guys all tomorrow for the first double digits, day 10. Peace out.